Welcome back, everyone. In this video, I'm going to talk about continue talking with the fourth part of the this presentation, which is related to privacy. Okay, so how personal is information? This is actually a term. The terms personal information and the personally identifiable information are often used interchangeably in legislative frameworks as well as in different technical literature. How personal is information? For example, let's say his name is it can be personal information like the date of the birth or financial information and name and health in information and merit information about family information about education in terms of this this is a personal information. And if we move to the location, what kind of devices and what person is searching on the internet and what eating habits and entertainment, and it can be related to outside the work, related to work information, related to where the person is being is at, and what type of clothing. I mean, there is a very diverse uh, 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 types of information that are available, which can be identified as personal and personally identifiable information. That if information is collected and a person is identifiable by the information, and if a person is and what information is actually related to at what type of level is personal information is at about a person. So, for example, date of birth is considered personal information, but not personally identifiable information because it cannot uniquely identify an individual. To estimate the likelihood of a specific person to be correctly re-identified, even in a heavily incomplete data set, only a small number of features need to be linked to identify an individual from a population. For example, facial features, fingerprint, scan, scan fingerprint, which can be DNA. These are the minute number of features that are available, if available, even in a heavily data set, which is even in incomplete, that individual can be identified very easily. And privacy preserving technologies. Now, at this stage, even in 5G and 6G, there are actually privacy preserving technologies. So, let's see. As 5G networks evolve, it is expected that there will be increasing reliance on AI-enabled smart application requiring situational, context-aware, and customized privacy solutions. Blockchain can offer privacy-preserving data sharing mechanisms, optimize the and access control, provide, provide key characteristics such as data integrity, traceability, monitoring, and ensure efficient accountability mechanisms among the other aspects, and is seen as relevant option for example in the machine type communications in 6G. Different privacy operates by perturbing the actual data using artificial design, random noise function before sending the final output to the assigned server. These are different technologies, different mechanisms, different policies by which privacy is preserved in 5G and in 6G. So at the end of the this presentation, I'm going to talk about the standardization and regulatory aspects. Protection of individuals' privacy and identity have long been a challenge for standardization body, since different nations have widely different perspectives and regulation in this area. This statement is uh, seems have little significance, but in reality, this is a very huge burden on even on nations and standardization bodies from a very long time. A future which sees us working via our digital avatars in virtual reality or augmented reality or material presence will also have health and safety issues. This is a given. New legal consequences may arise around industrial relations in a digital mirrored workplace where telepresence and hours are essential parts of the production system and human employees work in collaboration. Uh, if we talk like this and we portray like this, then this seems a very good benefit. But in actuality, at the backside of how this is going to be implemented, there are there are many concerns that arise in terms of confidentiality, in terms of integrity, and in terms of privacy. Furthermore, the future digital and physical worlds will be deeply entangled. Malicious cyber activities can lead to loss of property and even life. Attribution of responsibility in the case of physical harm caused by a digital twin or automated system against a human is a compelling legal issue. Legal question will always remain. At the end of the day, at the end of the discussion, at the end of everything, only one question remains: who is liable? Because everything can be done in negligence, in not being 100% responsible, and in being careless, and in identifying if there was an intention or it was unintended to harm the person, or if it was malicious or not. So there's a very fine line, a very thin line between the who is responsible and who is liable, and how is it liable. So this is also a headache for the standardization bodies to regulate and to create policies that eventually decide who and how is everything liable, and what will the effects be. So thank you guys. Thank you for listening to this presentation, and it's a very long presentation which includes up to 7 videos. So be sure to watch the videos if you have any comments, and you can actually contact. Thank you.